I want to talk about the final derivative rule that we need to learn, and it's called the chain rule. The chain rule is going to help us when we have what's called a composition, where you can interpret an expression as plugging a function into another function. Okay? Some examples of compositions are, let's say, plugging in 2 times x into the square root function, or plugging 3x into the sine of x function. All right, those are 2 examples. Now, you could prove the result I'm going to give you by carefully analyzing the derivative limit for this situation. I'm not going to do that in this video, but I'm just going to present the result. Okay, so the situation is this. If you have such a beast, okay, and you want the derivative of that, I'll put a little prime symbol. What that's equal to is you first find the derivative of the f function as if the g wasn't even around. Okay, so that's f prime. But now you go and plug g of x into that. And then you multiply that by g prime of x, the derivative of that g function. Okay? Now, some examples are clearly in order here. Okay? So let's do the square root of 2x. Okay? So on the bottom of the whiteboard, if f for that situation above, that example, the outer function was the square root function, and the function that I'm plugging into that was the g of x equal to 2x. Okay? So can you see that if I was to, with these definitions, if I was to write f of g of x, that's the square root of 2x. Okay, so now you forget about the composition for a second and find the derivative of f and g with x, with respect to x. So f prime of x is 1 over 2 root x, or however you want to write it. G prime of x is 2. Okay, and all of that is to get us ready to plug into the chain rule formula. So f prime of g of x, so that means 1 over 2 square root, and now I'm going to plug in g now. The g is 2x, so that's what's going to go in underneath the square root. And then g prime of x, well, that's just 2. So there you have it. Now you can simplify. So we have 1 over the square root of 2x. Okay? It looks like a lot of work. If you look at the red markings, it was pretty involved. However, after you do enough of these, you'll be able to do a lot of this in your head, and you'll be able to just quickly write down the answer much more conveniently. Okay? Let's do another example. The sine of 3x. Okay, and I'm running out of room, so I'm going to go on a new whiteboard. Let me copy the chain rule formula again. So this applies when we have a composition, as it's called, and we want to find the derivative of it. And so that's the formula that we get. And so the sine of 3x. Okay, so in this case, I like to think of the composition kind of like an onion with layers. So the outer layer, if that helps in this expression, the function, the f function, is sine of x. That's the one that we're substituting a function into. G of x, the inner function, is 3 of x. Okay? You can see that that's true because now if you plug g into the f function, you get sine of 3x. Okay? So now let's go ahead and crank out the derivative stuff. So the derivative of f is cosine. The derivative of g is 3. And so now, but we don't want f prime of x, we want f prime of g of x. F prime of 3x is cosine of 3x. Okay, so putting it all together, we get for our final formula, let's write it upstairs, upper right. Cosine of 3x times 3. Rearranging, we get 3 cosine 3x. That's probably the nicest way I could write it. All right. Now, a couple of words of warning. So, there's a difference when you talk about the derivative of a function. There's a difference if you talk about the derivative with respect to one variable versus another variable. When I wrote f prime, what I meant by that was I'm taking the derivative with respect to x. So I have to find f prime of x, I have to go back to the original f of x. This, I'll circle it in blue. This is what you take the derivative of. Okay? Don't take the derivative of what I'm going to circle in purple. Don't take the derivative of f of g of x. Okay? That would be a different derivative altogether. You go back to the original f of x and g of x. Okay? Now, in order to make it more explicit what you're taking the derivative with respect to, some people use an alternative notation for derivatives, which I can introduce you to now. So if you want to take the derivative of f with respect to x, I'll put this in the bottom right. You can also write that the derivative of f with respect to x. Okay? If you want to take the derivative of g with respect to x, you can write that as the derivative of g with respect to x, that way. Okay, with little d's, lowercase d's. Okay? So let me now finish by doing some more examples. So what about x? What about, let's see, what about 2x plus 4 cubed? And what about 1 over 7 minus x? Let's do both of those and then we'll close. All right, so for the first function, for the first expression, the outer function, the outer layer of the onion is x cubed. What are we cubing in the first function? Can you see that we're cubing 2x plus 4? So 2x plus 4 is the inner function, or the g. Okay, in the last one, the outer function, the f function, you can interpret it as 1 over x, the inverse function. What are we inverting? We're inverting in the last problem we're inverting 7 minus x. All right, so that's what g of x has to equal. So let me make that correction. (7 minus x). Okay, so now we take our derivatives. So f prime of x is 3x squared. G prime of x is equal to 2. That's for the first one. For the second one, I don't know why I'm doing them both at the same time. G prime of x is minus 1. Now, again, what I was saying before, let's be clear. Now now that we found f prime with respect to x, now we plug g into the f prime function. The f prime again with respect to x. So f prime of g of x is 3 times 2x plus 4 squared. Okay, in the bottom one, f prime of g of x is minus 1 over 7 minus x squared. Okay, putting it all together. So using the derivative formula, the chain rule formula. I hope you wrote it down. You'll have to memorize it. You'll end up memorizing it in spite of yourself because you'll use it so much. So putting it all together, the first one, I'll write it in blue. 3 times 2x plus 4 squared times 2. Okay, so you can simplify that to 6 times 2x plus 4 squared. The bottom one, minus 1 over 7 minus x squared times minus 1 simplifies to 1 over 7 minus x squared.